Kia ora, Year 12 and 13. Here's the next exciting instalment of last year's Differentiation Level 3 exam. So this video is going to have 3 little questions in it. The first 2 are achieved questions and the third one's a merit question. They should all be pretty quick. So the first one is this one here. We have to differentiate a quotient. So we're going to, not surprisingly, use the quotient rule. So let's get into it. So we start off by writing dy by dx and we square the denominator. Right, so if you want to write this out with your u's and v's as you've got on the formula sheet, go for your life. I just usually get straight into it. So we'll square the bottom line and then we copy that up here and we just write down x squared plus 1. Now we look at the numerator and we differentiate that, 2e to the 2x. Now we switch around, minus the derivative of the denominator, which is 2x, times e to the 2x. Now it says you don't need to simplify your answer, but I can't not simplify my answer, so I'm going to simplify it. Just skip this 30 seconds of video. So we've got x squared plus 1 all squared, and then I've got 2e to the 2x, and then x squared plus 1 minus 2x, and that cleans up to give me this 2e to the 2x times x minus 1 all squared over x squared plus 1 squared. But you know, if you were sitting in the exam and they told you not to simplify, don't simplify, just stop there. Okay, 3b, what have we got? We've got another parametric question. So this is the second one in last year's paper that had parametric in it, but this one's quite a lot easier than the first one. So we've got a curve defined parametrically by these two equations, and we have to find just the gradient of the tangent to this curve where t equals 0. So what do I need to do here? Well, dy by dx, when I've got parametric, is dy by dt divided by dx by dt. And that's just another application of the chain rule, which comes up everywhere in calculus. So dy by dt is equal to 10e to the 5t, and dx by dt is equal to what? 10e to the power of 2t. So that's just chain ruling on that. That gives us dy by dx is equal to 10e to the 5t over 10e to the 2t, and that equals e to the power of 3t. And we just have to evaluate that at the point where t equals 0. So now we have to substitute in. And we get e to the power of 3 times 0, which is simply 1. Now notice what we'd have to do if we needed to find the equation of the tangent or the equation of the normal. We'd need the point with coordinates x, y. So if we had to do that, then we'd take t equals 0 and we would chuck it into each of those things there. And that would give me the point for the tangent line. And just one more thing to revise that's not in the question. If you're asked about the normal, that means that we would take this gradient and we'd go -1 over that because the normal and the tangent are perpendicular to each other. Okay, on to 3c. So this is a merit question, and I think when you first look at it, it looks like it's hard. I actually think it could be in a level 2 paper because there's not that much to it. So we've got a parabola, an inverted parabola, y is equal to 15 minus x squared, and we've got an isosceles triangle, OAB. So here's OAB, and we want to figure out the maximum possible area of the triangle. So all it is an upside down triangle. This thing here is the base, and this is the height. And we know that the area of a triangle can be found by half the base times the height. So let's write down that as an expression. So area is equal to half base times height. Now, what do we have to do? Well, we go back up in here and we look for some coordinates. And we say, well, what is this base? We know that the triangle's isosceles, so we know that this side and this side are the same. But this point B here is going to move up and down. And this is just x, and the y value is 15 minus x squared. So if this bit out here goes from 0 to x, the whole of the base is just twice that. So the base is 2x. And the height is given by the y value. Right? So it's a half times 2x times 15 minus x squared. So hopefully now you too are wondering why this is in a level 3 paper and not a level 2 paper. 15x minus x cubed. To minimize something, we go like this. dA by dx is equal to 15 minus 3x squared, which is equal to 0 for a maximum. So solving that gives me 3x squared equals 15, x squared equals 5, x equals plus or minus root 5. But we haven't quite finished because, as usual, what we're interested in is to find the maximum possible area. Now, we don't need to show that it's a maximum, so that speeds us up. So a couple of ways to go here. We can just substitute in our value of x into the area function. And that's what I'm going to do. So we're going to use x is equal to root 5. You could use the negative 1. Let me think about whether that will matter. That would give you a negative area, which would be kind of weird. So the area is going to be 15 root 5 minus root 5 cubed. So working slowly through this, I get 15 root 5 minus 5 root 5, and I'm collecting up like terms, and I get my final answer is 10 root 5, which I think is 22 point something 36 to 2 dp. Now I haven't been given units, I don't think. No units. So the units would be just units squared. So there you go. 3 pretty, I think, easier than usual questions for the achieved and merit bit of question 3. I'll be back soon with 3D and then 3E.